Right. Okay. So today's session is going to build on what we did last week. So if you recall what we did last week, we covered learning unit 6, and we went over the normal distribution. Now that is used extensively in learning unit 7. So it's very important that you understand how to use the normal distribution to get the probabilities using the table at the back of your book. All right, so let me share my whiteboard to kind of give you an idea of what it's all about. Share my screen in a second. Okay, so just share my whiteboard. If you don't see it, please just let me know. If you can just unmute and just tell me that you can't see it. But I'm just going to assume that you can see it. All right, so just ignore the text on the top. I'm going to kind of explain what the normal, what this learning unit is about. So whatever I'm going to show you right now, you're not going to be tested on it. It's more for you to have an understanding of what this learning unit is about. I'll come to a point where I'll tell you, okay, this is where you need to focus and pay attention, because this is what's going to be relevant for your exam. Okay, so right now what I'm going to show you, it's not going to be, you're not going to be tested on it in your exam, but it does help you to understand what this learning unit is all about. Okay, so in last week's session, what we covered is that I showed you that data that can be represented by a histogram that's symmetrical. And what I mean by symmetrical is there's your histogram, there's your, whatever this data is measured, okay? Can be anything, be measured in class marks, maybe the production life of some product in a factory, etc. Right? So, etc. Okay, so let's assume now I join the edges of a graph like that. Okay, and now if I remove these blocks, and I'm just left with this graph. And let's just say that this graph is symmetrical. It's bell-shaped. What I mean is that if I had to draw a line down the center where the peak is, say the peak is here, and I draw a line down the center, then this half here is exactly the same as this half is the same. That's what symmetrical means, okay? Then that tends to follow a normal distribution. And what's useful about a normal distribution is that once we know its mean, whatever the center is, and we know its standard deviation, the width of it, okay, that's sigma. If we know these two things, then we can find the probabilities of what we're trying to measure using the table in the back of our book, right? Okay, so that's what last week's session was all about. Now, today, okay, what this is about is, let's just say there's 7 of us right now in the class, right? Let's say each of us draw a sample. So what we do is, say we go to a factory, and the first person gets a sample, and say we're measuring the lifespan of batteries, okay? So the first person, right? Let's say student number 1 in this room, student number 1, you will draw, let's say, 100 batteries. You go to the factory and you take 100 batteries. You sample 100 of them, right? You sample 100 and you create a histogram for it. Yes, right, etc. Right? And then you, from your sample of the 100, you get the average of that sample, and that average would be somewhere around here, right? Whatever your average is. Let's say the lifespan. You sample 100 batteries. You just have to measure the average lifespan, and let's say the average lifespan of all those batteries is, let's say, 2 months. Okay, 2 months. So we're measuring in months. And then student number 2 goes to the factory and they draw, let's say, 150 instead. So they draw a bigger sample and they also create a histogram. Right? So they create a histogram that's up their data set. Okay, etc., etc. You get the idea. I don't have to draw it too neat. And they found that average is maybe around about 2.5, etc. Okay, and we continue in this fashion. So this is student number 1, student number 2, and let's say we get up to over 30 students. So let's say there were more students in this class. There was 35 students, okay, all the way up to 35 students. Right, so remember I said 35. Write this inside. Remember, you're not getting tested on this. I'm just trying to explain to you what we're trying to do and what this learning is about. You got the 35th student, and they did the same thing. They drew, let's say, 125 of these batteries, and they got their histogram, etc. Okay, all right. Now, what is useful from this approach is that each of us, student number 1, they got an average for their sample. And if you remember from the first learning unit, the symbol for the average of a sample is this X bar. So student number 1 got an average of 2. So their X bar was 2, right? Then student number 2, their X bar was 2.5. And so this is student number 1, student number 2, and so on. And we got all the way up to the 35th student. Okay. I'm going to clear this out. There's some space here. It's a bit cluttered. Okay, all the way to 30, all the way to the say 31st student, and their X bar was, let's say, 2.2. Right, so we got this, got a whole bunch of data points here. Got about 35 data points here for X bar. What we can do with this collection of averages for each sample is that these averages, these X bar, they also follow a normal distribution. So they will also follow a normal distribution. So if I had all the X bars on the axis, they would also follow a normal distribution. And where it would be centered, okay, is where the true mean is. So for instance, what the true mean is, remember we went into a factory, okay? Each of us just drew samples. But if we had to go and look at every single battery in this factory, and let's say the number of batteries in this factory is 1 million. Let's say there's 1 million of them, right? If there was 1 million of these batteries, then we could get the true average because we got everything. We didn't take samples. And that true average, right, if we had to average it, is what would be the mu. That's your true average. Okay? And in practice, we can't really go and get the true average. Sometimes the production manager has to tell us what they believe is the true average. Because to count every single one, it might not be worthwhile in terms of time, and it might be too expensive. It's not practical. So we generally get an indication of it from, the what we call the expert or the domain expert, whoever is in this factory and runs this factory. All right. So why it's useful is because whenever we draw a sample, say any of us draw a sample, say I draw a sample of 100. If I want to work out what is the chance of the average of the sample being greater than, let's say, 1 month, for instance, I can work this out based on this information. You can use this theory to answer this. So if ever we want to work out the probability of an average of a sample, we can use this theory. And I'll show you how to apply this theory. You don't have to know how to do it right now. I'm going to show you how to do it. But I just want to make sure that does that make sense. Remember, you're not tested on this, but do you have an idea of what I just said, or are you completely lost? I'm just going to check the chat. So the idea of this whole learning unit is to get the probabilities of the sample. So before, comment in the chat. So I'm just going to assume everything's okay. last week, let me just kind of summarize it like this. If I just sum it up all about one idea, then I'll kind of just show that now. Right, so just give me a minute to clear this out. Okay, so keeping with that example of the batteries in a factory, right? If you stick with that example, you go into a factory. Okay, this is a inside this factory, there's batteries. If you draw just one battery, let's say one battery here, right? If we just draw one battery and we want to know what's the probability that that one battery has a lifespan of over 1 month, then that one battery we will represent by X. Okay, so we want to know what is the probability that that battery has a lifespan of more than 1 month. Right. Now, the second person, instead of looking at one battery, they take a sample. Okay, so they take a bag, and in this bag they collect 50 batteries. So in this bag there are 50 of these batteries, 1, 2, 3, etc. Okay, so there's many X's. So there's 50 of these batteries here, 50 of them. And because you have 50 batteries, you can get an average lifespan because you're not just looking at one battery. And if I want to know what's the probability of the average lifespan of the batteries, then I would use this symbol instead of X bar. I'm looking at the average lifespan of that sample. Okay, that's what the X bar is. It's the average of those 50 batteries. I don't know what's the probability that the average of that sample is more than 1 month. That's the difference. So what we did last week was this. We looked at 1 unit. What we're doing now is we're looking at a sample and we're interested in finding the probability of the average of that sample. Okay, does that make sense? Everyone all good? Did I lose you? Thanks, Shakanibo. I hope I'm pronouncing your name correctly. Please forgive me if I'm not. But that's okay, great. Thanks for the feedback. All right, so this is what we did last week. This is what we did last week. This is what we're going to do now. Okay, now let's look at this first question on the left to kind of put things in perspective. Right. So the question, I'm just going to draw your attention to this one. Okay, this question here in the left block. So it says the mean lifespan of a brand name tire, okay, is 50,000 miles. Assume that the lifespan of the tires are normally distributed and the population standard deviation is 800 miles. So these values are going to be important. We'll use them in a second. Okay, so the mean 50,000 miles and the standard deviation is 800 miles. So in other words, the true mean, okay, of these tires is mu, and that is given as 50,000. And then your standard deviation, which is sigma, is 800. They're telling us, okay? First question says, if you select one tire, what is the probability that its lifespan is less than 48,500 miles? So what we're trying to measure is the lifespan of a tire, and that is X. So that is the lifespan of a tire, just one tire. It's never get confused the spelling of tire. It was TY, but anyway, it doesn't really matter. All right. So what they're asking us for question number A, okay? Question number A is, what is the probability that X is less than 48,500? That's what they're asking us. Okay, we need to solve this. And we would do this like how we did it last week. Okay, we need to convert this to a Z statistic. And how we do that is by using the formula Z equals X minus mu all over sigma. So if we had to draw it, we are trying to do this. This is what they're asking us. This is your x. It's centered at the mean, which is 50,000. Okay, 50,000. So there's your center. Okay, and they want us to work out what is the probability that x is less than 48,500. The 48,500 is on the left of 50,000 because it's less than that. So let's say it's somewhere around here. Let's just say somewhere. It doesn't have to be exact. We just need to have an idea whether it's on the left or the right. So 48,000. Right? So what's the probability of x being less than that? Okay, so there's your 48,500. To find that probability, that means we have to work out this area here. Okay, so this is what we did last week. Nothing new. Okay, this is just kind of the same thing we did last week. Right? They want us to work out this area. And if you work out this area, you'll get your answer. And how we do that is we need to convert this to Z and use the table in the back of our book. Okay, so here, this is now your Z axis. You got the same graph. Remember now, instead of being centered at 50,000, it's centered at 0. Okay, and we need to convert this 48,500 to an equivalent Z value. And how we get that equivalent Z value is by using this formula here. So you're going to plug in 48,500 into this X. You're going to use a mu of 50,000. As it is, there's a 50,000 for mu. And your sigma is 800. So that's what you would substitute for the denominator. You would substitute 800 there. You would substitute 50,000 here. And for your X, you're going to substitute 48,500. So if you put all those values into the equation, you get an equivalent Z value of minus 1.8. Minus 1.8 minus 1.8. Right? And so you just need to use the table in the back of your book to find the same area on the left of it, just like what we're trying to do here. Yeah, you're going to find this area in your book. And I'm not going to go over how to find the probability because I covered that last week. So if you're not sure, please just watch that video. Okay, I've covered it in a lot of detail of how to find these probabilities. So if you use the table in the back of your book, you'll find this probability is, the answer is 3.01%. Okay, that's the answer for question number A. That's the answer for question number A. Okay, that's your probability. I'll move on. I'm just going to check the chat. Good. Okay. All right. Now, let's move on to question number B. And question number B is something new. Okay, that's pertaining to this learning number 7. Okay, so that's question number A. So remove this formula. All right. Question number B. So we've answered A. Now we move on to question number B. Now, question B says you've selected 100 tires. So now it's not just one tire. You've selected 100 of them. Okay, so your sample size is N, which is 100. Okay, and the question is, what is the probability that their mean lifespan? So you've drawn the sample. Okay, so you've got the sample. There's 100 of these tires in it, 100 of them. And you want to know what's the probability of the mean life. So if you have 100 tires, if you had to get the average, we would represent it by X bar. If we had to get the average of these 100 tires, we would represent it by X bar. And the question is asking us, what's the probability of that X bar? Probability of X bar being more than 50,200. That's what this question is asking us. Okay, does everyone understand this question, how I've written it? Does it make sense to you what they're asking in question B and how I've written it in terms of probability? Good. Thanks, JD. Okay. Thanks, Lakanito. Thank you very much. All right, so I'm going to go back to the whiteboard. Right, so everyone understands that? Okay. Now that you understand like how I've expressed it mathematically, okay, now we need to solve it. Okay, so we need to use the same table, the back of your textbook, to find it. But there's a little catch on how you convert it to a Z. Now, before, in question A, we use this formula. We use Z equals X minus mu all over sigma. So if we want to find the equivalent Z value for any given X, we would use this formula. But for X bar, formula is different. Okay, you have to use this formula. You have to use Z equals X bar because we're not interested in X anymore. We have X bar. So X bar minus mu all over, and the denominator is sigma over square root n. That's your denominator. That's the difference now in these two formulas. You can see the differences in the denominator, and instead of X, we have X bar. Okay, so this is the formula you're going to use, and it's given to you in your formula sheet. You don't need to memorize it. Okay, this is the formula you're going to use. So I'm going to erase this one, so we're not going to deal with it now. So I'm just going to make it a bit neater. Right, so we're going to use this formula. Z equals to X bar minus mu. All right, so that means what we have is, okay, we have this graph. Here. And instead of X on the axis, we have X bar. Okay, that's we're trying to look at the sample mean. X bar, that is centered at the true mean, 50,000. Right? And they're asking us the probability of X bar being greater than 50,200. So 50,200 is on the right of 50,000 because it's more than 50,000. It's about 200 more. So it doesn't have to be exact. Let's put it here. Okay, so at this point, okay, that's where 50,200 is. And we want to know the probability of X bar being greater than that. So that means everything on the right is greater than. That's, we need to work at this area here. That's what we need to get. So now what we're going to do is we need to convert this X bar to Z. And why we have to do that is because the table to give us these probabilities are only in terms of Z and not in terms of this lifespan of tires. We don't have a table for every single thing that is normally distributed. We have to be able to convert it to Z. And how we convert it to Z is by using this formula here that I put in this box. Okay? So now I'm going to convert it to Z using that formula. So yeah, okay, this is my equivalent Z curve. And now remember it's Z on the axis and it's centered at 0. And I need to convert this 50,200, this value here, to a Z value. And how I do that is by using this formula here. So I'm going to put 50,200 into my X bar, because that's what the X bar is. My mu doesn't change, it is still 50,000. My sigma, okay, is 800. And my n, okay, is what's given to me in question B, 100 tires. So there's your n. You have all the values to put into this equation. And if you do that, you'll get a Z value. You put all these values into the equation, you get a Z value of 2.5. So that converts to, this 50,000 converts to 2.5. And so we're asking the same thing for the area on the right of this value, but now in terms of Z. And this we can solve using our table in the back of our book. And remember, I did this last week. So this now becomes probability of Z greater than 2.5. Okay, and just like how we did it last week, use the table in the back of your book, you'll find the probability is 0.62%. Okay, what is important that I've done so far is that you understand how to formulate this, okay, and then how to go from X bar to Z using this formula here. And then you get an equivalent diagram for X bar like how I've done here. So this, you should understand how to go from that diagram to this diagram and find that probability. Finding this probability is what we did last week. Okay, so everything makes sense so far, except this last step, because that I know I did last week. But everything before that is very important that you understand that. Okay, before I move on. All good? Anything you want me to go back and explain? People, everyone understand that when we have to find out when we write the final answer, do we write it in the first way you wrote the probability? Okay, so let me see your final answer. Okay, your final answer will be this. Okay, and this is the value you need to write in the end. And I guess you're asking is, are you asking if you should write probability of Z greater than 2.5? Okay, equals 0.62%. So yes, you need to write this one, this part here. Okay, so basically you're showing what is the equivalent probability for Z, right? When you have this. So what's that equivalent to in terms of Z? So that you've got to write, and then you've got to write what that value is in terms of percentage. Even if you leave it as a decimal, it's still fine, but you still need to give this final answer, showing that you've used the table to find it. Does that answer your question? Okay. Write it in terms of Z. Okay, there's another reason why you should write in terms of Z, is because say you get the final answer wrong, okay, but you will get marked for kind of each line of working. So if you show that probability of Z, so that means if you show the step, here, you can get marked for it. So show it, okay, more for your workings, should I say. So if you had to somehow get this answer wrong, if you showed this and you got it right, you will get a mark for that. So show it. Show all your workings. Okay, pretty much everything I've done in this on this whiteboard, show it what I've done here. Okay, that's gonna increase your chance of getting more marks. You're welcome. Okay, is everyone okay with this? I don't. Before I move on, if I don't hear anything, people, I don't know if you're following or not. I might just move on to the next question. So is everyone okay with what I did? Is anyone not sure about anything you want me to go back and explain it? Now is the time. But let me know. Hey. So JD, that 0.62%, that's what I did last week. Okay, but I'll go over it again, but that's what I did last week. Okay, so didn't want to do it because then it just means we're covering what I did last week, but I will show it now. All right, so I'm going to start from, say, here. Okay, and to do this, I'm going to require you to do the workings with me. Okay, so you need to have your textbook in your table here and your calculator here. Okay, so I can ensure that you're following. So please have your textbook with you and have your calculator with you, right? Because I'm going to need you to put the answers in the chat. All right. So for the second question, question B, they're asking us for the probability of X bar greater than 50,200. Okay, so from what I gathered earlier in the chat, you all understood that the question is asking us to solve this. Right? So now, if I had to draw it in a diagram, okay, sorry, I had to draw it here on a diagram. This axis is your X bar. It is centered at 50,000 because that's what our mu is. So you remember, this is centered at mu. Excuse me. And it wants us to work with the probability that X bar is greater than 50,200. So this is X bar on your horizontal axis. Okay, so 50,200 is on the right of 50,000, so it's somewhere here. It doesn't have to be exact, but we know it's on the right. Okay, so they're asking us to work out the probability that X bar is greater than 50,000. So greater than means everything on the right of this. If I had to shade it, it's everything on the right of it. And finding the area gives us this probability. So if we find this area, that is the answer. Okay, that's the probability. So this is the answer. Okay, before I move on, everyone okay with that? Everyone? Can you say okay? All right. Okay. Now, to get this probability, we need to use the Z table. Okay, so the Z equivalent. So now we have Z on this axis, and instead of centered at 50,000, it's centered at 0. And if you're not sure why it's centered at 0, okay, this is covered last week. Okay, so you do need to watch that lesson and catch up with that, please. Right? So I'm going to just sketch this graph. Right. Okay, so there's 0, it's centered at 0. Now, what we need to do is, remember, we're trying to work out the area on the right of 50,200 for X bar. So we need to figure out what is the equivalent Z value for 50,200. Okay, what does that map to in terms of Z? And that is obtained by using this formula here. Z equals X bar minus mu over sigma over square root. So there's your mu, there's your sigma, your n is your sample size, n is 100. If you look at the question, it tells us it's 100. So you have mu, you have sigma, you have n, and what you would put for X bar is whatever X bar value you're trying to get the equivalent Z values, that's what you're going to put in. So for us, we're interested in 50,200. So you're going to put 50,200 into X bar, right? So please do that in your calculator now. I want you to put all these values into this equation and tell me what Z value you get. So you're going to put 50,200 for X bar, 50,000 for mu, 800 for sigma, and 100 for n. Do that and write the answer in the chat for me. Check that. Okay, do that. Your n is 100. Very good, Haley. Very good. Okay. You should get a value of 2.5. Okay, you put all the value into the equation and you get a Z value of 2.5. Okay, 2.5. So that means the equivalent of 50,200, okay, for X bar is the same as Z being 2.5. So what we need to do is find the area on the right of this, because we're looking for the area on the right of it, remember? So we need to find this area here on the right of it. Okay, and if we do that, then that's the answer. Okay, now how are we going to do that is we use a table in the back of our book. Right, now I'm going to shade this area in green. Okay, now remember, using that normal table, the back of your book, right, you can get the area from 0 to any z value. And in this case, the z value is 2.5, right? So you're going to go into your textbook, open a table, and get this value for the green area. Okay, because that's what the table tells you. It tells you the area from 0 to any z value on the right of it. Okay, so if you're not sure, let me try to open the textbook to kind of show you the diagram. Second, let's find my textbook. There we go. So I'm gonna try and get to that page. Okay, so that's a T table, this is the Z table. So remember that this table, if you give it any Z value, which is found in the borders of this table, so if we're looking at 2.5, then 2 is down here, okay, and 2.5, the second decimal is here. So where they intersect, that's the area from 0 to 2.5. So what value do you get in your table? Can you write that in the chat? Because that area that you're giving in the chat, that's going to be the area, the green area. Anyone? Okay, very good. That's right. That's the area. That's the green area. 4798.4798. So let's go back there. So this green area, okay, is 0.4798. Okay. Now we're not interested in the green area. We want the blue area. But we need that green area to get the blue. Okay, and how we find that is, remember from last week, half the area of the graph is 0.5. So that means you have 50% on the left and 50% on the right. So if the entire area here, right, the entire area on the right is 50%, and if the green makes up 0.479, then how much is the blue area? Well, that is simply just taking 0.5 minus 0.4798. Right, and that should give you that 0.62% that I was talking about. You subtract that too, and that's what you're left with. That leaves you with the blue area. Does that make sense? If you work that out, that should give you something like 0.6%. Does that make sense? Okay. Jessica, question?
Sorry, that was a mistake.
Okay.
Yeah.
No worries. Okay. All right. So please, if you're not sure how to find these probabilities, go back and watch last week's session. Remember, I did tell you that last week's session is very important because it carries over to this week's, to Learning Unit 7 and Learning Unit 8. So if you don't understand last week's session, you're going to struggle with learning unit 7 and learning unit 8. So please recap that. Watch that video until you understand everything thoroughly. And if you're not sure about anything, you've got to let me know. Drop me a mail. Tell me what you're not sure about, okay? You got to tell me what you're struggling with for me to help you. So please familiarize yourself with last week's session. Very, very important. All right. Let's move on. One more thing I want to cover for this learning unit. All right. So that's question A and B done. I'm just going to clear the board. We're going to do a new question. Okay, so we've answered the question on the left. Now we're going to answer the question on the right. Okay, and there's a difference between the two. And the difference is that for the first question, we were talking about averages. That is the average lifespan of a tire. Okay, for this one, we're going to talk about proportions, okay, percentages, right? We can still use the normal distribution or the table in the back of a book to find the probabilities, but how we convert to Z is different. So if you read the question on the right, it says that in a certain neighborhood, it is known, right back, it is known that 12% of school leavers are unemployed. It is known. You draw a random sample of 150 school leavers, right? So that's your sample. So that's your N. Okay, that's your sample size. Your N is of 150. Right? You draw a sample of 150 school leavers, and then you want to know what is the probability of that sample containing less than 15% unemployed. Okay, so let's just start with the first line. First line of this says, it is known that 12% of school leavers are unemployed. So that isn't calculated, that's given to you by what they assume and what they claim. So they believe that that is the true percentage of unemployed people, right? And the true proportion is represented by pi. If we represent the true proportion by pi, and that is 12%. Okay. Now what happens is, in this neighborhood, you can't go and count every single person and see who's unemployed. It's just not practical. So the best you can do is you take a sample of people. Okay, how you sample them is not important, but you sample 150 people, right? And let's just say here are the 150 people in this room or whatever, wherever you have them, okay? You can count all of them because they're only 150, and out of those 150, you want to determine what percentage of them, right, are unemployed, right? That's what you're trying to figure out. You got 150 people here. You're just interested in what is that percent of people that are unemployed. So what you're trying to figure out is, if you look at the last part of this question, what's the probability that the sample contains less than 15% unemployed people? So you're being asked, what is the probability that that percentage that you work out from these people, right? We're going to represent it as P. Okay, that's what we're trying to work out. What's the chance that the percentage of people that are unemployed in the sample is less than 15%? That's what you're being asked. Does everyone understand that before I move on? Let's get it. Thanks, Lakanibo. Thank you. All right. So that's what we're being asked, okay? What's the chance that that percentage of unemployed people from that sample is less than 15%? Okay, so what happens is now, to work like this. So last week's session we had X. Earlier on today we had X bar, but now it's P on this axis, proportion. Okay, so here, this is your diagram distribution. Just pretend it's symmetric. That's the best I can do for drawing it like that. Now you have proportion on this axis, and where it's centered would be where the true proportion value is, pi. You don't need to understand why this is so. You just need to understand that it is actually so. Okay, the theory behind this is actually too extensive, and you don't need to cover it. Okay, you actually need to dedicate like another 2 weeks or something to it. But you don't need to understand why that proportion will be centered at the true proportion value. Okay, you just need to understand that it is so, right? Okay, so your proportion that you're trying to measure from the sample would follow a normal distribution that is centered at the true value. Okay, now we want to work out the probability that P is less than 15%. Now, what is our true value that's given to us? It's 12%. Okay, it's 12%. So that means this true value is 12%. And they're asking for the probability of P being less than 15%. So 15% is on the right of this. It's more than 12%. It's here. It's here. 15 will be somewhere here. All right? And they're asking the probability of P being less than that. So less than 15% means everything on the left of it. So I'm going to shade this in 2 different colors. So this part in black, and then the other remaining part in green. Yeah. Okay, so you need to understand that this, let me write this again. This question, what they're asking us, they're saying P less than 15%. So that means everything less than 15%, all the way to infinity, everything. Okay, that's what it means. It didn't say this 0 less than P less than 15%. It didn't say that. If it did say that, then we will only be talking about the black area, because we're talking about the area between, sorry, not 12, 0, not, sorry, 12. It's not asking us for the area between 12 and 15. Okay, it's asking us for everything below 15. So that means 15 here and everything below it. So that means you need to find the area for the entire graph when it's below 15%. So that means the black area and the green area, right? And if you know those values, then you've answered the question. Because if you find that area, that is the probability. Okay, so they're not asking us this, they are asking us this here. Now to find the green area, that's actually easy. Now remember what we did last week? Remember what we said, this graph is split into 50% on the left and 50% on the right. Okay, 50% on the right. So that means this pi 12%, that's the halfway mark, right? So if I had to sketch the equivalent Z curve, so I'm going to draw that below it. Something like that. Okay, so now it's Z, and that is centered where it's centered at 12% for P, it's going to be centered at 0 for Z. Okay, so the green area is everything on the left of 0. And what do you think that area is? What do you think the value of the green area is? Only the green area. So write it in the chat. What do you think it is? You actually don't even need to look at the table. Remember what I told you? The total area is 100%. And this graph is symmetrical about 0. So that means everything on the left of 0 is identical to everything on the right of 0. So what do you think this green area is? Very good. Excellent. 0.5. It's 50%. Nicely done. Very good. So this green area is 0.5. 0.5. So we've got the green area. So we're almost there. Okay, almost there. The only thing we need to work on now is this black area. So yeah, redraw it in terms of Z. Yeah. We need to figure out what this area here is in black. And if we know that, Once we figure it out, then we just add the 50% to that and figured it out. We've answered it. All right. Now, same approach like before. Okay. It's going to be 12% here. Right, but okay. Remember, we're looking for the area on the left of 15%. So it means we need to convert this 15% to a Z value. What's the equivalent Z value? So we're going from P to Z. And we need to figure out how do we convert P to Z. Fortunately, there's a formula to do that, and you don't need to memorize it. Okay, the formula is Z equals P minus pi all over square root pi into 1 minus, I know it's a lot, sorry, I know it's a lot, but just feel comforted that you don't have to memorize the formula. It is given to you. You just need to know how to use it. So 1 minus pi all over n. Right, so this everything in the bottom of the denominator is under the square root sign. Okay, so you know what your P is. Your P is 15%. That's given to us. Your pi in this formula is also given to us. It's 12%. It is here. And your n in this formula is 150. So you have everything to substitute into this formula. What I would encourage you to do, and you don't have to follow my approach here, is I tend to work out the denominator separately. I do it separately, and then I put it back in the formula. So that denominator, everything that's in the denominator is known as your standard error. Okay, just worth knowing what that term is. So your standard error is the denominator. So your standard error is the denominator. So it's basically that square root pi into 1 minus pi all over n. Everything's under the square root. And if you work it out by putting all these values in, you'll get a value of 0.027. 0.027. So that's just the denominator. So what this formula here, this whole thing ends up becoming is Z equals P is 15%. Okay, minus your pi, which is 12%, all over 0.027. All right, and if you plug that in, your answer is, your Z value, should I say, is 1.11. 1.11. So that equivalent 15% in terms of P is the same thing as Z being 1.11. 1.11. Okay, and you know how to find this probability using your table, because just like how you did it earlier, it's the same thing. You're looking for the area from 0 to 1.11. Okay, and you should be able to do that. Okay, so if you pull that out, I think this total should be something, your total area, your final answer should be 86.65%. So it's something like this black area here should be something like, space here, you look at your textbook, you can actually do it now while I'm doing it. It should be 0.3665. 665. So if you add this and this, then that's your final answer. The final answer is 86.65%. That's it. Everyone, understand that? All good? Is everything clear? Thank you. All right. Any questions? Please let me know if anything wasn't clear. Finding the probabilities using the table. Yes, please. You need to watch last week's session. This week's session, what is important, the takeaway points are, is you need to be able, let me clear the board. So let me put a whole board. Okay, you need to be able to go from X bar to Z and then find the probabilities using the table. Using the Z table. Right? So this is what we covered last week. This week, you just need to know the extra step here. Now you don't have X, you have X bar. You need to go to X bar to Z and then find the probabilities. In the second part of this lesson, we went from P to Z, and then everything else follows. Okay, so it's just these two extra parts that we've covered in today's learning unit. Okay, this part here on the right, everything here we did last week. So please familiarize yourself with this, because you're going to be doing this, finding probabilities using that Z table, even for the next learning unit as well. Okay, so it's very important that you understand how to do that. Okay, does that make sense, everyone? What is the mathematical symbol of the area under the curve? That's a good question. So, okay, so for this course, okay, in this course, the area, let me put it this way. Okay, so let's go, let's draw this. In terms of Z, there's your Z axis, and it's always centered at 0. Okay, so Z value is always centered at 0. Now, for any Z value in this axis, you can call it whatever you want. I'm going to call it, to keep with your textbook, they use small z. Okay, so okay, maybe my z's are the same. Let me use a big Z just so you don't get confused. This is your Z axis, and this is for any value. You can call it A. Let's avoid confusion. Let's call it A. I'll give it any symbol, but I'm going to call it A. And if I want to know, okay, if I want to know the probability, that Z is between 0, Z is between 0 and A. This is how I write it mathematically. How I say Z is between 0 and A. So if I want to know the probability that Z lies between these two values, right, the probability that Z lies between these two values, this is how I write it mathematically. And what this is actually asking me for, what this is this area. That's all it is. This area is the same thing. This area that I'm shading is the same thing as that. So if you found the area, you've found the same thing what this is asking for. Okay, that's how it's shown in this course. Generally, and if you want to be technical, and I'm not encouraging you to learn this and confuse yourself, generally this here, we use the symbol here, and I think it's theta, capital theta, right? If we say theta of, let's say A, like this, what this actually means is find the area for everything below A, not just A and 0, but also this part here. That's in general how normal distribution probabilities are notated or described. So, like I said, you don't need to know this. I'm just answering the question that you asked. If you see the symbol here, phi of A, in terms of a normal distribution, that means they're asking you to find the area under the curve for everything less than A. So this entire black area. So, does that answer your question? You're welcome. Hey, everyone, all good? Does that make sense? Are there any questions?
Sorry.
Yes, Jessica.
Hi, I just want to check when our assignment is. Is it in May?
Well, I don't have that timeline with me at the moment.
Okay.
It'll be on your PAS though, your latest PAS.
Okay. All right, so I'll have a look. Thank you.
No worries. Correction, is the third edition of the prescribed textbook sufficient? Third. Oof. We're on fifth. Eric, I would say fourth, just to be safe. At least fourth edition you could get away with. Third is quite old. So I'm not, yeah. Honestly, I can't really answer that. But I would say just to be safe, fourth edition. Thanks, Sherry. I think Sherry put the date in the chat, Jessica. It's 6 May, I believe. Second, yes. So the answer for that last question is 86.65%. Yeah. You're welcome. All right, everyone. That's it for me this evening. Yeah, but if you're not sure, please drop me a mail. But we'll work through those problems, okay? I made a practice test available for you as well. So you can work through that as part of your revision. But please watch last week's session. If you're not comfortable with finding these probabilities, please watch last week's session and also work through the exercise that I gave you in the announcements, okay, to consolidate your understanding. Please make sure you do that before next week's session, okay, because you can't be lost in next week's session. It's very important that you familiarize yourself with finding these probabilities using the normal distribution. Okay, and then that is it from my side. And thanks for joining, everyone. I'll make the recording available tomorrow. All right, have a good evening.